What's up guys, this is Massey. Welcome to another video. In this video I want to talk about applications of the dot product. Let's start with an example. Here in this example we need to find out the work done. Angela has entered the wheelchair division of a marathon race. While training, she races her wheelchair up a 300 meters hill with the constant force of 500 Newton applied at an angle of 30 degrees to the surface of the hill. Find the work done by Angela to the nearest 100 joule. So since we want to find out the work done, we need to find out the dot product of force and displacement. Force is 500 degrees and displacement is going to be 300 meters, but it is going to be the surface is going to be on the hill with 30 degrees. So it's going to be 300 times cosine 30. So the dot product is going to be 500 times 300 times cosine 30. And the answer is going to be 129,904. Or we can approximately have it as 129,900. Let's see another example. Find out the angle between two vectors. Determine the angle between the two vectors in each pair. We have g 5 and 1 and vector h -3 and 8. What we need to do, we need to use the formula of dot product. G dot h equals to magnitude of g times magnitude of h times cosine theta. So we can simply find out the dot product of g and h, which will be 5 and -3, that will be -15 plus 1 times 8, which is +8. So -15 plus 8 is going to be -7. So the dot product of g and h is -7. On the other hand, we need to find out the magnitude of vector g and magnitude of vector h. Magnitude of vector g is going to be 5 squared from +1 squared to the power of half, or square root of 5 squared plus 1 squared. And vector h is going to be square root of -3 squared plus 8 squared. So then theta is going to be cosine inverse -7 over root 26 times root 73. And then we can say theta is 99.246 degrees, or approximately 99.2. Part B, we need to find out the angle between the other two vectors, s, which is -3 and 6, t is 4 and 2. So we need to do exactly the same thing. We need to find out the dot product for s and t. That will be -3 times 4, that's -12. 6 and 2 is going to be +12. So -12 and +12 is going to be 0. So since the dot product of s and t is 0, and since the magnitude of s and magnitude of t are non-zero, we can say these two vectors are perpendicular to each other. We had it on the previous video. So part B, we can say since the dot product is 0, the theta, which is the angle between s and t, is 90 degrees, and these vectors are orthogonal. How to find the angle between two vectors? We can say cosine theta equals to the dot product of u and v divided by magnitude of u times magnitude of v. Vector projection. You can think of a vector projection like a shadow. Consider the following diagram where the vertical arrows represents light from above. Think of the projection of v on u as the shadow that v cast on u. If the angle between v and u is less than 90 degrees, then the projection of v on u, or projection of v on u, that's how you write it, is the vector component of v in the direction of u. If the angle between v and u is between 90 and 180, the direction of projection v on the u is opposite to the direction of u. If v is perpendicular to u, then v casts no shadow because the theta is 90 degrees, so the projection is going to be 0. Let's see this example. We need to find out the projection of one vector on another. Find the projection of V on U if theta is between 0 and 90 degrees. And part B, it says do the same thing when theta is between 90 and 180. So we need to construct CD perpendicular to AB, and we're gonna have AD. So AD is projection of V on U. So AD will be equal to V times cosine theta. So that's gonna give you the magnitude of the projection. So now we can say that the projection of V on U equals to the magnitude of V times cosine theta times U divided by magnitude of U. If theta is between 90 and 880 degrees, then we can say projection of V on U equals to, again, magnitude of V times cosine theta times U divided by magnitude of U. So now we can define this formula, the projection of V on U, where theta is the angle between V and U, is projection of V on U equals to the magnitude of V times cosine theta times vector U divided by magnitude of U. Or you can say the dot product of V and U divided by dot product of U and U times vector U. If theta is between 0 and 90, then we have dot product of U and V divided by magnitude of U. If it's between 90 and 180 degrees, then it's going to be negative dot product of U and V divided by magnitude of U. Now let's see this example. Part A says projection of U on V. V is 1, the magnitude of V is 1, magnitude of U is 5, and the angle between is 50 degrees. So when we sub it in the formula, then we're going to have, since theta is less than 90, that's going to be U times cosine theta. So we have 5 times cosine 50. That will be 3.21. And part B is greater than 90 degrees. That's 120. Magnitude of P is 20. Magnitude of Q is 30. And we want to find out the projection of P on Q. So since theta is greater than 90, the magnitude of the projection is given by negative P times cosine theta. So negative 20 times cosine 120, that's going to be 10. So as you see here, since the theta is greater than 90, the direction of projection is opposite to the direction of Q. Now let's see the part C. Part C says determine the projection of D 2 and negative 3 on C, which is 1 and 4. Then we can say we need to use this formula. We have the dot product of D and C over dot product of C and C times C. So it's going to be 2 times 1 plus negative 3 times 4 divided by 1 squared plus 4 squared multiplied by 1 and 4. Then when you multiply it, it's going to be the vector negative 10 over 17 and negative 40 over 17. Note that the direction of projection is opposite to direction of C because that's going to be greater than 90 degrees. And let's see the last part, illustrate projection in parts A to D. So A is going to be, as you see, like that. This is the U. And V, the projection is going to be 3.21. That's how you see that. Part B is going to be like that. As you see here, the theta is greater than 90. So that's why the projection is going to be the opposite direction to Q. And part C is like that. It's going to be in 2 opposite direction. That's why we figured out the negative number. Let's see another example. Dot product in sales. Shoe store sold 350 pairs of Excalibur shoes and 275 pairs of Camelot shoes in a year. Excalibur shoes sell for $175 and Camelot shoes sell for $250. Write the Cartesian vectors as to represent the number of pairs of shoes sold. Part B, write the Cartesian vector P to represent the price for the shoes and find the dot product of S and P what does this dot product represent? So S is going to be 350 and 275. P is going to be 175 and 250. So the dot product is going to be 130,000. The dot product represents their revenue. So the number of shoes sold times the price. Now let's see the key concepts. And to wrap up this video, to find the angle theta between two Cartesian vectors u and v, use the formula cosine theta equals to the dot product of u and v divided by the magnitude of u times magnitude of v. For two vectors u and v with an angle of theta between them, the projection of v on u is the vector component of v in the direction of u. So the projection of v over u is going to be magnitude of v times cosine theta, or it's going to be the dot product of v and u divided by dot product of u and u. If theta is between 0 and 90, then we have v times cosine theta. If it's between 90 and 180, it's going to be negative v times cosine theta. So the projection is going to be the dot product of u and v divided by u. If theta is between 0 and 90, then projection is the same direction as u. If 90 and 180, then the projection is going to be the opposite direction as u. And if you have 90 degrees, then there is no shadow and we have a 0 vector for the projection.